All right, last one, pH. So with the pH meters, there is a couple things that you need to make sure. First of all, that it'll turn on, and does, which is good. If it's not, you'll want to replace the batteries. In order to replace the batteries, you'll want to unscrew the top like so, and replace the batteries on the top. They are labeled the direction they should go. Make sure when you put the cap back on it's not canted, or else it will misthread these. So I usually press it on so that's level. I'll sometimes back it out as well until it clips and then grabs on the threads, and then you can go all the way down to the O-ring. Make sure it's tight, not too tight, but tight enough that it makes a seal. At this point, there should be a cap on here that goes on like so. Press the on-off button here, and it should go on. For everyday sampling, you get a sample. You can open the cap like this. Make sure you don't lose the cap. And what you'll want to do is do not touch this bulb. This bulb is very sensitive and will break if it's knocked against rocks and things like that. What I'll do is I'll gently swirl here, and then you can read what the pH is. In this case, it's 8.7, it looks like. You may want to wait for it to stabilize. Now, it's very important before, I've already done it with this one, but with all of your pH meters, you'll want to just soak them in a KCl solution, which is this right here, potassium chloride. And this will basically prep the probes so that they're soaked and ready to go. You can also soak them in water for like 5-10ish minutes. If they've been in long-term storage, it's best to soak them in this first. And then you'll want to rinse them off in some water afterwards. There may be some salt buildup in and around the bulb area. You'll want to just rinse that out. Again, do not touch the bulb or scrub it with anything, because that will damage the bulb. In this case, again, you just wait for it to stabilize. It is stabilizing now. It's kind of going between 8.0, 8.1, which is good. And that is what you can have the students record on their sheet, which will tell you what how good the pH is over here, which is in this case excellent for this water quality. This is just tap water that we're testing it on. You can also take a look. There is temperature readings here as well that you can use instead of a thermometer if you so wish. If you're going to use these the next day, you can just rinse them off and then cap them directly like so. If you're going to store them for any length of time, again, make sure that the device is off, and you'll also want to put a few drops of this pH electrode solution. It is made up of KCl, potassium chloride, and you just put a couple drops in the cap. Should be a sponge on the bottom, and by putting a couple drops of this on here, you'll make sure that the probes, oops, that's a little bit too much. If you did put a little bit too much, you can just pour it back out there. But you want to make sure that this probe here is moist. Now, you may have an out-of-date maintenance and calibration thing. It'll tell you just to air dry it. If you can, do not air dry it for either long-term storage or any type of storage. You want to store it in this. These were created before we as a department got this maintenance and calibration kit here. So store it just in here. You'll notice that the probe itself and the glass is actually touching that sponge. That is totally fine. It is in contact with that KCl solution, which will extend this probe's life. So sample in a container like this. Do not sample in the cap. That cap is just for this storage solution stuff here. You can Alternatively, use the salinity one. Just fill the water up to the 20 mil mark. This will fit just fine in here. All right. So yeah, again, make sure things are rinsed off for regular use. There may be some salt buildup. Just rinse that off with tap water or deionized water if you have it, and store it with the KCl solution. Make sure the cap is on to protect that bulb when not in use. What I'll do sometimes as well is I'll rinse and just dry the outside, again not touching anywhere near the bulb, just to make sure that the KCl here is good. So for long-term storage, you're going to do same kind of thing. Get as much KCl into here so that the sponge is moist with it, and even you can see a little bit of drops underneath there as well. Even if it's super saturated, that's kind of what you want. Put that on here, make sure it's making a good seal and not just falling off the bottom. In that case, you may have to replace the rubber O-ring. And for long-term storage, you'll want to uncap this and take out the batteries. Very important. You don't want those batteries corroding in there, because if they do, they're going to wreck the probe. So I would take the batteries out for long-term storage and put them in the Ziploc bag, or a Ziploc bag, so that they won't do anything. For now, I'm just going to keep the batteries in because I'm going to be using this, and I'm going to show you how to calibrate this properly. So for calibration, again, if it's been a while, you'll want to soak it in the KCl solution. This you can actually return. So what I'll usually do is get a dry beaker or something like that, or a dry one of these containers. Fill them up with KCl, put it in. But usually I'll do more than one if I'm calibrating. So I'll get a dry version of this, put a little bit of KCl on the bottom, and put all the pH probes inside that need to be soaked. After they've soaked, I will then return the KCl back here. It's just salt water, basically super saturated salt water, but with a very special type of salt. And that right there you can return in there if it's not been contaminated. If this is completely wet and you contaminated it, maybe not use it, but this I'm sure you can return if these were stored fairly dryish or with KCl solution already inside. You can just soak that in. So to calibrate, again, you want to turn it on like that. This one here has been soaking, so it's pretty good. You'll want to start off with the lightest color one, which is a pH 7 buffer solution. And sometimes this is all you really need. You just need to put the probe into the pH 7 buffer and calibrate at it. Wait for the readings to stabilize, and you'll notice that this one's a tad off. It's not bad. Sometimes you'll get it very, very off from what it should be. This one here in particular was at 7.9, 8.0, very, very out of tune. This is one of the old ones that I have, but you'll notice that it's kept calibration pretty good. Again, you'll want to wait quite a bit of time for it to stabilize. I would say, 5-ish minutes. In this case, I'm not going to do that because it's very close and I've already calibrated it. So in order to calibrate it, you just press and hold the cal button right here, and the CA will come up 7.0. It automatically senses what kind of calibration it needs to do, and then it'll say SA for save. That's great, and end, and we're there. So there we go. This is usually the kind of calibration you just need to do. This is called a one-point calibration because you're just doing one calibration using the pH 7 buffer. After you're done with this, you can take it out. Make sure you can rinse it. Rinse it under running water, preferably. Just because I'm doing it with you here and now, and it's kind of awkward to get things running, I'm just going to rinse it off with this. Ideally, you do it with distilled or deionized water. I'm not doing that right now either. but we'll just rinse it off, get that pH 7 buffer out. And after you do that, you can just store it back with the cap if you're just doing a 1 point. If you want to make it a little more accurate, you can go through the other buffer solutions. We have a pH 4 and a pH 10 buffer solution here. I like to do it by color here, go from lightest to darkest. You always start off with pH 7, and you can just do that. If you want afterwards to do a 2 point or even 3 point, you can do either one of these. So I'm going to go next with the pH 4. Again, there's some water on here, so what I'm going to do is just dab off some from the outside. Again, I'm not worried about the bulb because I don't want to touch it, but I'm just going to wipe it off from the outside like this, just so that I don't introduce any water or contamination over here that might affect the buffer solution here. So I'm just going to put it in here, and it should be pH 4. I'm just going to wait for the readings to stabilize. You can swirl it around a bit if you like. Swirl it a little bit. And again, it's very close over here. 4.2. It may actually go down to 4.1. We'll see. If not, we'll press the cal button. But it's close, which is a good thing. Now, it's also very important that all these buffer solutions are the same temperature. So don't store them too cold, too hot. Make sure they're all stored in the same place. That way, when you're ready to sample, you're good to go. And all right, it's kind of stabilized at 4.2, so we're going to calibrate now. So press and hold. 4.0 should come up now. There we go. And that matches the pH 4 here. And it'll say save now, and then it'll say end. And we're good to go. Now you can just stop at that if you want, just do 2 point, which is totally fine. That's kind of helps with things over here. If you want to go super accurate, do the last one. I'm going to show you that just because I can. So remember, make sure it's rinsed properly. Again, running water helps a lot, but again, making sure that pH 4 buffer solution's out. If you do leave some of it on and go to the blue, it's actually going to react and make it less than 10. And that is going to definitely affect the calibration you're doing. So here we go. That's good. We're almost at a pH 7 here, which is good. Just from rinsing it out here. That's good. All right. So I'm like the previous one, I'm just going to wipe off the outside and put it in the blue one next. All right. And you'll see over here we're at 10. That's really good. There you go. So since we've done these two calibrations, it should be at 10 or very close to it. In this case, 10.1. That's fine. So we can just press the cal button here, and it'll finish calibrating. Again, maybe wait a minute or two more for it to stabilize. And I'm stirring it a little bit too, so that's good. Looks fine. I'm going to press the cal button, and it's recognizing it's a 10. That's good. If it's not, you just press the up button and it'll kind of switch between 4, 7, or 10, because sometimes it's way out of whack if they've been stored improperly. There we go, and we're done here. So with the calibration solutions, I would not reuse them. I would just dump them. If you run out of this stuff over here, the KCL, the electrode storage solution, you could use pH 7 buffer. Do not use these two, but you can use this to store it. This is preferred though, to the pH 7 buffer solution. But if you, for whatever reason, run out of the electrode solution, definitely store it wet. It will increase the life of the probe, and you can store it in pH 7 buffer if you need to. And that includes the cap as well, putting stuff in the cap. But make sure it's rinsed off properly, and that, and then you can store it properly over here in with the cap. Again, put a few drops of the storage solution or a little bit more. Make sure that's is soaked and wet, and that way it's good to go. So I'm just rinsing this off again. You can rinse it off in running water as well. We're almost at a pH of 7 here, which is good. That just tells me that most of the buffer has been rinsed off. There we go. Alright, yep, it's pH 7-ish. That's good. And I'm just going to wipe off the outside. There we go, not touching that bulb. Put this on in here, shut it off, and we're good. Again, long-term storage, I would take out the batteries, but otherwise, you're good to go with this.